And we're back. This time we're going to be tackling the steering of the motorcycle. So initially, I thought we would use the stubs, the leftover stubs from the handlebar, to mount some sort of servo arm or something onto. But I think it may be a better idea to go down low onto the lower triple tree. So the control mechanism needs to be up top when a human's riding this machine, but it doesn't matter where it is if a machine is piloting it. We can also easily mount something under the frame right here on either side. You know, we can have a bracket that extends out, and we can mount a servo arm. At that point we can have ball joints or something else that stick out to allow our arms to articulate. What's nice is that the system will be symmetrical. I plan on having, although you could control the steering of this machine theoretically, you could control it from one side. It would be nice to have redundancy built in, so that the machine can actually have half of its system fail, considering that it's going into pretty hostile environments by the very nature of its purpose in life. So I'm just going to take some of these objects and move them out. So these triple tree components are currently a part of the main symmetry group, just because that's the way they were modeled. And in order to change that, I'm going to have to break them out of symmetry. So the ignition switch can go by itself. This bolt can go. I'm just cutting and pasting. The rest of this stuff looks like it's like it lives in the symmetry object. So what I can do, the easiest way I think, is just to duplicate the entire symmetry object and then delete anything that is not part of our equation. So we have a second symmetry object here. Anything not in the symmetry group has to go. So what we're left with is just the objects that are symmetrical, a copy of them. And we can then remove the tail, the undertail, and the frame, leaving us with a new symmetry group containing only those parts. We can then move the origin up here where it makes sense. Move our new symmetry unit into the front end hierarchy so that we can select the front end now. Move its pivot point down to the pivot point of the bike steering. Like that. It seems to be off on the x-axis, so I'll just zero that out. Just like that. And now we can rotate the front. I will notice that the symmetry stuff from before is still left behind. So we can just remove those triple trees. And there's also these ignition switch and bolt items that we cut and paste. We can just grab those and put them into the front end group, because that's where they belong. So we've done a little bit of cleanup. We can now rotate the front end, and that's going to help us a little bit when we create the steering. Looks like the bar ends didn't make it, so I'm just going to cut and paste them into the front end. So now we should have our entire front end detachable and transformable. So now we need to figure out what these connecting rods are going to look like. I've created systems similar to this for client work before. Also concept stuff. So I'm just going to start with a 12 segment cylinder. Y-axis is fine. Scale it down. One of my hobbies when I'm not doing 3D modeling is RC helicopter flying, I guess. Just toy helicopters. I like them because they're very challenging. They're very difficult to control. They're difficult to fly and nearly impossible to master. There are very few people who can fly RC helicopters and really make it look effortless. And RC helicopters have servos to control linkages that ultimately control things like the swash plate, the pitch of the blades, all these other cool radio controlled concepts. So I'm going to replicate what RC helicopters do with my servo mechanism here. We're going to start with this bar. So this bar is going to be a push rod of sorts. I'm just going to group it so I can move its origin. And Cinema 4D, you cannot move the axis of an object that still has construction history. And that basically means that you cannot rotate a cylinder from its base. However, by grouping the object, we can create a new origin and a new point to rotate it from. So we can rotate this cylinder toward its goal. One thing we don't want is we don't want this linkage to touch the frame. So it might be a good idea to go below the frame because we have a lot more clearance down there. So this is where Cinema 4D actually has a few cool tools for us. I've found the best way to make a believable steering linkage like this is to actually build the steering linkage. So it would be really cool if this linkage always pointed to its destination, and we can do that. All we have to do is create a null object. I'm going to place it just outboard of the fork tube, and then we can move it up here. So it's going to connect to the fork tube right around there, just on the outside of it. Now what we're going to do is we're going to tell this object, we're going to call this steering push rod, because I can't think of a better name. And we tell the steering push rod to essentially look at the null object. So now if we move the... Oh, I put it in the wrong slot. It needs to be the target, not the up vector. So now we move the null around and we can see something's happening, but it's not quite right. The axis is incorrect. So what I can do is I can actually rotate the null object 90 degrees. And roughly what we now have is a bar that follows a target object. If we were to place this target object, so I'm going to call this target right because it's the right side. If we were to place this in the front end group and then rotate the front end group, we get sometimes the rotation tools and the orbit tools snap when I'm doing a screen recording, some sort of a conflict. So we can actually move those around like that. Now of course it's staying in one spot. That's not how it should work. So maybe we should reverse our approach. What I mean by that is, let's remove that target object, and first let's make a copy of the target right, and let's transfer the target right's position to where the push rod is. So now it's down here. We can zero out its rotation because it doesn't need to be rotated. Only its position matters. And we can delete the old, let's leave the old target. We can take the steering push rod and now we can move it to the old target. So now the steering push rod is over here and we can put it in the front end. And then we can move the new target outside of it. It's kind of confusing, but what I basically did is reverse the position of them. So we can put that target tag back on the push rod and then tell it to look at the right target. Now when we rotate the front end, push rod moves. Now I'm just going to say this up front, I am not sure if this would work in real life or here in Cinema 4D. I'm just trying some stuff. Let's see if it works. So we can take our push rod, probably need to adjust its size a little bit so it fits between the 2 points. Now the real trick here is going to be creating the part of the servo that sits here. I'm not really sure what that's going to look like. It's probably going to be some sort of a throw arm and a central motor point. And if RC helicopters have taught me anything, it should be perpendicular to the push rod. So the way it would look if this was an RC helicopter is we'd start with a cylinder, scale it down a bunch. Let's give it 16 rotation segments, flip it around on the x-axis. So what this is going to be, so I'm going to rotate it so it's roughly, its coordinate system is perpendicular to the rod, and then we move it away. So that's where our motor would be, right there. We can scale it down, and then we're going to make it editable. That way we can start to manipulate it. So I'm just going to optimize it to make sure all of the points are welded. And then we can start to stretch it. Hopefully what we'll get is a shape similar to the shape I'm used to seeing on servos, the servo arm. And if I'm speaking a little slowly, it's just, as I've mentioned before, this is kind of tricky to do while speaking. It's not that it requires a lot of concentration, I've just never practiced speaking while I do this, so my speech might be a bit annoying or disjointed. So here we have what sort of looks like a servo arm. It's probably going to be nice and beefy like that, so that'll be a nice opportunity to drill some of the material and play with that aspect a little bit. And now that I look at this, the servo is probably going to have to sit lower as the frame is in the way. So if we rotate this 180 degrees, the servo will probably have to be down there somewhere. Like that. Now this is where it gets tricky. we can see what the problem is. If I move the steering, the rod pulls away, but it pulls away in a few different axes. So it's actually going to, we're actually going to have to make this sort of a clever system. I'm not sure how to do it yet. I'm just sort of thinking, because this servo arm is only going to be able to rotate in one axis. And if we push the servo arm forward to rotate the steering, you can see that's quite far away from it now. And how do we fix that? We could try, let's see, target. Oh, I see. If our target object was a child of the cylinder, and we move this cylinder forward while we rotated the front end, it would stay fairly well aligned. So we would need a ball joint on the inside and a ball joint on the outside. And then we would need to rotate these in tandem. And that can be done with some espresso. So let's set that up real quick, because this is basically all the moving parts for one side. If we can get these going, then we can just repeat it for the other side. I'll probably do that, not screencasting, and that way there won't be another 40-minute long screencast. Let's give this a bit more throw. So the distance this can push the push rod increases the longer it is. So right now it can do something like that. And that's the throw that it has. We can increase that by moving it away from the rotation point. And what I'm thinking is we're going to need a little bit more throw. So let's try it like this. We just move the target. Now what I'm doing here is I'm creating low detail stand-ins. So I just want to see this work, and then once I know how it's going to work, I can then create the models and actually change the way it actually looks. I can make it a lot more detailed, a lot more beefy looking. For now it just looks like a lobe shape and a rod, but we're going to have pieces that clamp to the front suspension as well. And there's going to be a servo motor behind here. Maybe I should put a stand-in for the servo. That might have a nice side effect of giving us things to parent other objects to. So the idea about the servo is the servo usually has a certain amount of left and right rotation. And it doesn't matter what orientation the servo is in, so I'm going to align it with the frame. What does matter is what orientation the servo arm is placed on the servo with. So your servo can be at a funny angle as long as the servo arm is mounted properly on it. And it has grooves, it sort of has splines on it that allow you to change the orientation of the servo arm versus the servo itself. So let's say our servo is going to be that large. We have a low profile servo on this machine because the Daemon has that kind of technology. So we can see it just fits. It's going to be a big, bulky piece of equipment if it needs to be powerful enough. Then again, maybe it doesn't have to be. Let's cheat a little bit. So that's what our servo is going to look like. We're not intersecting with the other parts too badly. And it looks like we can easily have a bracket that mounts on. And we can put one of those on either side of the bike. We may have to reroute this air intake, but I'm okay with that. While we're getting rid of parts, let's just get rid of that one. It looked really good on the real bike, but this is now a autonomous killing machine. Alright, so onto the Espresso. What I normally do is, instead of directly selecting the front end and moving it using the manipulation tools, I create a slider. So it doesn't matter where the slider is, you can put it anywhere you want, but for consistency I'm going to create a null object and I'm going to call it Razorback. In the future, as we complete this model, we can place all of the other parts of it under that object in the hierarchy. We can also create an Espresso tag on it. We get our Espresso editor. And here in the Razorback object, if we go to the User Data tab, we can add user data. The first bit of data we're going to add is steering. Well, I didn't mean to do that, so let's edit the entry. So it's going to be steering, it's going to be animatable, the interface will be a float, it'll be a percent, it'll be degrees, the step will be 1 degree in the when you drag the slider. The minimum limit will be -25, the maximum limit will be 25. Oh, one other thing, the interface is going to be a float slider. So it looks like this. So we can adjust the steering left and right. So now we can adjust the steering left and right 25 degrees. First thing we do is we move the Razorback object in here. This allows us to access that user data field as steering. It's going to output whatever value we choose in the attribute editor. Then we need to get the object we want to manipulate. So here we have the front end object, and it's basically the steering object. Everything that has to do with steering the bike left and right is pretty much going to live in here, but what I often like to do is to group it. When you group an object like this, you get an extra null object that it has local coordinates with. For instance, if I were to look at the object coordinates of the front end by itself, it has a position and it has a rotation already. Actually, it looks like it has heading, pitch, and banking rotation. It shouldn't. It should just have pitch. So let's correct that, first of all. So what I've just done is I've made sure that this axis is square, plumb. It should be over the pivot point, and it should be at the same angle of the steering. Now, we can adjust these values here, but it's easier to adjust the values if they're zeroed out. So if we group the front end, we get a null object, and the front end under it, relative to its parent, which has the same position, is now 0, which makes it much easier to animate. So we call this null object steering, because I like descriptive names. Now we add steering to our Espresso pool, and now we can simply drag the steering property, which is output in degrees, and we can connect it to the rotation H for heading. Now, fingers crossed, we should be able to select the Razorback and adjust the steering. Now it looks like it's not working properly. You see how it's steering strangely? Ah, because I did it wrong. I didn't want to get steering in there. That was the whole reason I grouped it. What I actually want is I want to call this steering group. And I want to rename front end. Well, let's just leave it as front end. Front end is the actual object that we want to steer. So we go to coordinates, rotation H. And because it's working with local coordinates now, it should behave the way we'd expect. It steers like a motorcycle or a bicycle. Now, the cool thing is because this position of this object is being driven off of a calculated slider like this, we can drive other things using that same value. Now in Espresso, you can usually only have one thing controlling this rotation, but you can use this steering attribute to control many other things. In this case, the servo arm. Now the servo arm suffers from that same local coordinate issue, so we're also going to group it. And I'm going to call this right servo pivot group. And the servo geometry, I'm going to group it as well. That way we have a null object and we can swap the geometry out. I'm going to call this right servo arm. And we can put right servo arm in here, and we can connect the, let's see, which coordinate are we editing when we rotate this? The pitch. So we can connect the steering to the rotation P, rotation pitch. So in a very rudimentary example, what we have here is when we adjust our Razorback steering, the servo arm moves as well. It's good stuff, except it moves incorrectly. It's going backwards, and it's probably not moving the right amount. 1 degree of servo throw is probably not going to equal 1 degree of steering because we just threw this geometry together. So what we need to do is intercept this value and change it. We do that with an Espresso calculate range mapper. The range mapper allows you to take an input value and map it to an output value on a scale of 0 to 1, 0 to 100, 0 to 1000, whatever scale you want. So when we have our range mapper selected, we can see that currently the data type is real, that's fine. The input range can be degrees, the output range can be degrees, but we can change what the input and output are. For instance, we know that our input lower is going to be -25, and we know our input upper is going to be 25, because that's what the steering outputs. Then we can determine what our output upper and output lower needs to be, and it'll map the steering amount to the servo arm amount. So we can just reconnect it. Now when we move our Razorback steering, you can see the servo behaves quite differently. So what we want to do is when we're turned fully right, well, you know what? That brings me up to another good point. We can actually use a negate, calculate negate to flip this value. So if we negate the steering value, we drag our slider left, and it'll actually move our steering left, because right now it's flipped, but this negate object flips it again. So now left is left and right is right. So if we go all the way to the left, the servo arms rotation is going to want to be forward. So what we can do is select our range mapper and say 0, 0. And we can see the output upper or lower. We can actually interactively drag it and say we want the output lower to be -45. How about that? And then we move our steering the other way, and we say, go back to the range mapper, and we say we want our output upper to be 40. So now what we have is we have the beginning of a steering system where we're actually using a servo to control how much the steering moves. If we look at it from the top, we can see that it looks good. The only requisite is that this needs to be a ball joint on both ends. So I'm going to leave it at that, and I'm actually going to get the other side to this point, and then we can continue.